Shalom to you. In this video, we'll look at synthetic division, with which we could find zeros of polynomial functions of higher degrees. Okay, synthetic division is simply a shortcut to long division, but it has some limitations. We can use it when we have a linear factor with a degree of 1, and just like this, when we have a binomial that is two terms and with a degree of 1 and a variable and a number like that. So we just divide. This is in factored form, so in the zero form is going to be, of course, x equals 3. So we change the sign and use this. So what we do, we just take the coefficients of all the terms, keeping in mind that all the degrees must be accounted for. Here we have to the power 4, we are missing to the power 3, so we put 0 there. So we take the coefficient, which is 1, so we have 1, and the third degree is coefficient of 0, second degree will be 7, and first degree will be negative 12, and then the constant is 9. Okay, so once we have these, we put we are dividing by 3. So we bring down, drop down 1, always drop down the first one, and then we go, I'm gonna use different color, multiply, and then write our answer here. So 3 times 1 is 3, and then we're going to add 0 plus 3 is 3. And then next we multiply again and then write our answer here. So 3 times 3 is 9, we add, we get 16. Okay, and the next we'll do the same thing. Okay, purple and blue don't seem to rhyme, so 3 times 16, 48, and then we add, we get 36. And then we do the same, very messy. 3 times 36, get 108, we add, we get 117. So this last one is the remainder. This is the remainder if we divide this polynomial. And so what is left, again, this is the remainder. So we usually put the remainder over the divisor, which is x minus 3. And so we're going to add it to what this is going to be our constant term, a new constant term, so which is 36. And then this is going to be, again, it go in the order, in the decreasing order. So this is going to be positive, so this is 16x, and then this is going to be 3x squared. Again, 16 is positive, and then this will be 1, but we don't write that 1, we just write 1x and to the third power. So whenever we divide, the degree reduces. You see, we started with our fourth degree, now we have third degree, and so that would be our answer. So we just do this one step, we have a remainder, and we can check this in our calculator to see if the remainder is really 117. So we'll check that later here. We'll check that later. So next we do the same thing. So here again we have degree of 3, degree of 2. We are missing degree of 1, so we're going to put that 2, 13. So we're missing 1, we put 0 there. So always remember that. And then since we have x plus 3, we are going to divide by x by -3. And so, oops, I need some space, a little more space there to write my number. Okay, so dividing by working with 3. So we drop down 2. Okay, -3 times 2 is -6. And then we add, we get 7. And that times that, I get 21, -21. And then we add, I get -21. Okay, we do that. So we multiply that, we get like 60. Negative times negative is positive, so 63. We add, we get -1. So again, this is the remainder. So remainder is -1 over our divisor. Okay, so and our constant term is a -1. And this minus, we can just put it here. So, and this becomes 7x, and this positive, and this becomes 2x squared. Again, the degree reduces again because it's 3, degree of 3, we end up with degree of 2. I mean, with long division, we could divide more, but synthetic goes just 1. Since there is no, if the remainder is 0, we can, when we find factors, then we can do it again and again. So, all right. So we're going to use that, what is it? Synthetic division is a shortcut. It helps us to, instead of the long division, and we're going to use it shortly. So finding, looking at this theorem, it says when we divide polynomial, of course, this is the numerator is the dividend, the denominator is the divisor. Then what we get, the answer we get after we divide is the quotient, and sometimes we have a remainder. The remainder is over the divisor. Again, so if it's written this way, so what happened here, because we can, if we multiply both sides by the denominator, it's going to multiply the quotient. So that's what we see here. So there is a remainder theorem is saying that if f is a polynomial and we divide by a factor, if we divide by a factor of x minus c, then the remainder is f of c. So which means we can substitute c in the polynomial, and then whatever answer we get is actually the remainder. So we're going to use it to check those two we did, see if we get the same thing. And then another theorem like it is the factor theorem, saying that if x minus c is a factor of f of x, it's only if the remainder is 0. So if which makes sense when we divide normal numbers, like if we divide 6 divided by 3, there will be no remainder. The remainder will be 0. That's how we know that 3 is a factor of 6. So likewise, if an expression is a factor of a polynomial, if we divide it, the remainder will be 0. So these two, they go together. So we can use it to, so the if and only if f of c, if f of c is equals 0, then x minus c is a factor of f of x. Secondly, if x minus c is a factor of x, of f of x, then f of c is 0. So they go to either way. So is this x plus 3 a factor of this polynomial? So we're going to check it. We're going to find f of negative 3. Remember here where x is negative 3. So we're going to find what is it? Use synthetic division. See if we divide this, whether we're going to get a 0. So that's the synthetic division. After that, then we check it with a factor. So we check our degree. We have 5, 4, 3, 2, 1. So everything is complete. So we have these two and positive 5 and negative 2, positive 2, negative 2, positive 3. And then we are dividing by, okay, so we have negative 3. So we drop down 2. So we go how it goes now. Okay, so that gives us negative 6. We add, we get negative 1. Okay, so we have negative 3 times 1 is positive 3. We add, we get positive 1. And then negative 3 times 1 is negative 3. We add, we get negative 1. And negative 3 times negative 1 is it's positive 3. We add, we get 1. And then negative 3 times 1 is negative 3. We add, we get 0. Okay, so since we get 0 as our remainder, then x plus 3 is a factor. It is a factor. And then let's check it with our calculator and see if f of negative 3, would that give us 0 also to fulfill the factor theorem and the remainder theorem. So this is the remainder theorem. If the remainder is 0, then x plus 3 is a factor. If f of 3 is 0, then if x of 3 is a factor, then f of negative 3 must be 0. So let's check that with that in our calculator with all the other ones. Okay. So I can type these. Okay, that's the first one, 2x to the 5th to the 4th. So that's my y1. So keep where we type the y1, and then the first and second one we did. So it's good to know where we typed it. Then when we go to y verse, this is where it comes handy. I mean, you can do this manually also, plug that in, but it's going to take a while to compute. So it's faster when you to use the y verse. So I go to y verse and then function. I have it on y1 and then put in parentheses. I need my negative 3. This is when you really appreciate calculator like this. Okay, that checks. F of negative 3 is 0. So that fulfills the factor theorem and the remainder theorem. Then if we check, go to verse again, and let's check this time the y2, which is the one we typed in. We checked in the first one. We did f of 3. Check it to see what the remainder is. 117. That's what we got. Okay, and then the next one that we did in number 2, I typed it in here. Number 3. Again, it was negative 3. I think, and the remainder is negative 1. So that checks that whatever remainder you get when you do synthetic division is f of that factor. Is f of that factor. So you can actually use this to find the zeros very fast. or the remainder very fast. If you're not just asked to find, if you're asked to find the remainder of a polynomial, just simply substitute that number and then find the remainder. You don't have to do the long division, okay, if you're just looking for the remainder. But if you're looking for the quotient and the remainder, then you can do the whole the long division. Okay, but these tools can be really helpful. All right, let's find zeros then. Finding zeros of polynomial. When we find zeros, we can we need to find all the possible rational zeros. Okay, rational zeros. Of course, rational is anything you can write as a fraction like that. So, and then you can graph it if you want. Divide with synthetic division until you get a quadratic factor. Once you get a quadratic factor, then you can solve it by any of the ways you solve quadratic function, like factoring if it's factorable, or use quadratic formula. Okay, then to get the remaining zeros. So once you get it down to quadratic, keep reducing it. You can use synthetic to keep dividing it until you get to quadratic. Okay, let's do an example. So this is the highest degree of this is 4, so we expect to have at least 4 zeros. Okay, so we can use synthetic to find at least, or rather, let's find all the possible zeros and then test them, because for us to use synthetic, we have to have at least one factor to start with. So, so let's apply the rational zeros. So it's the P over Q. So P is going to be all the factors of 8. So it's going to be 8. And then the Q is going to be, so it's always the coefficient of the highest is Q, and then the constant is P. Now, so you're going to find all the possible factors of them. So all the possible factors of 8 would be plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. And all the possible factors of 2 would be plus or minus 1, plus or minus 2. And now, to find the possible rational zeros for this polynomial, we're going to take all the possible ratios for the top and the bottom combined. So we have so a PQ, we have either 1 over 1, which is 1, and again plus or minus, and then 1 over 2, which is 1/2. Okay. Okay, 1/2. Again, they're both positive and negative. And then, so 1 over 1, 1 over 2. Now we have 2 over 1, which is 2. So positive and negative 2. Okay, 2 over 1. And then we have 2 over 2, which is 1. We already have it. So 4 over 1, which is positive or negative 4. And then 4 over 2 is 2. So we already have it. 8 over 1, which is positive or negative 8. And then 8 over 2, which is 4. Okay, so these will be the possible rational zeros. Of course, there may be irrational ones, but this can only give us rational ones to start with. So let's test them. So there are how many of them here? 2, 4, 6, 8, 10. I mean, it will take forever to try to do synthetic division for all 10 of them until we find what we need. So I would use calculator to test them. Type this into the equation and then use our verse. Use our y verse. Okay, so can clear this. Okay, here, as I typed it in already at y4, so now I'm going to go to y verse. Okay, verse, I'll go to 4 and select 4. See how fast it can go. You can see this calculator is a lifesaver. Okay, I'm going to try each of these. Try +1, -1. So let's see if I'll get, which one will give me a remainder of 0. Okay, no, I don't have to be going back and to the verse. I can just select this and then change the number. I might try, maybe I'll try all the positive before I try the negative. I try 2. Okay, no, go back. Okay, I'll try 4. Oh, good. 4 gave me 0, so I'm going to go ahead. But since this is in the 4th degree, we might want to get at least 2, so that would take us down to quadratic. So let's try more, see if we find, so at least we have x equals 4 now. Let's find one more. Okay, 8. No. Okay. So let's try the negatives then. Oh, we didn't try 1/2. We could try 1/2 also. The positive 1/2. Okay, no. Okay, we'll go back. Maybe we try, we start with 1/2 now and try a negative 1/2. Oh, okay, negative 1/2 is good. It's another one. So we have 4 and negative 1/2. So now we use them. So there are 2 factors. Yeah, so that means if we do the synthetic division with 4 and then we can do with 1/2. Okay, so now I think I can just erase these. Okay. So, okay, do we have everything? So we have 2, -7, -8, 14, and 8. And we have 4 as our factor, as our 0. So we drop down 2. So we know how it goes. So 2 times 4 is 8. We add, we get 1. And then 4 times 1 is 4. We add, we get -4. 4 times -4 is -16. We add, we get -2. And then 4 times -2, it's -8. We add, we get 0, which we expect anyway because we already know that 4 is a 0. So we should get a remainder of a 0. Okay, so then what we have here is going to be -2, -4x, and x squared to x cubed. Okay, so this is where we are, and then we're going to, of course we have, it's like we have this factor x minus 4 times that. So this will give us back that. So we're going to do synthetic division again with this using the other 0 we have, which is -1/2. So if we have 2 and 1, and negative 4, and negative 2. Okay, so we're by negative 1/2. So watch the fraction we drop down to. So 1/2 times negative 1/2 will give us negative 1. Add, we get 0. Yes. Negative 1/2 times 0 is 0. We add, we get negative 4. Okay, negative 1/2 times, that is 2. We add, we get 0. And again, that's expected because we already know it's a factor. So now we have 2. So we have the constant, and then we have 0 in the ones, and then we have 2x squared. So we have x minus 4, x plus, x plus 1/2, and then 2x squared. Well, we have that 0, but then minus 4. Okay, this is what we come down to now. We have this quadratic. So if we look at this, if we put like 0x squared in the middle, multiply 2 times 4 and get negative 8. Is there any two number we can multiply and get negative 8 and then we add them and get 0? Yeah, no. So this is not a rational number. Therefore, we're going to, and of course, we tested all the possible rational numbers we had. So it's going to be a rational number. So we can use quadratic formula to find these zeros. Okay, sometimes it leads to that. Yeah, so this is negative b plus or minus square root of b squared minus 4ac all over 2a. And we know our a is 2, our b is 0, our c is negative 4. So plug them in. Negative 0 plus or minus square root of 0 squared minus 4 minus a is 2 minus negative 4 for c all over 2a is 2. Okay, so simplify. That's 0. 4 times that is 16, 32. 32. Okay, it's plus or minus 32 over 4. Now if we take the square, what can go into this 16? This 6 square root of 16 times square root of 2. That will give us square root of 32. So 16 is a perfect square. Okay, this is the plus or minus. 16 is a perfect square, so that will become 4. So 4 times 4 divided by 4 is 1. So we just have plus or minus square root of 2. Okay, so now we have all our zeros, which is x equals 4, x equals negative 1/2, x equals square root of 2, x equals negative square root of 2. So those are our 4 zeros. We have it. Okay? Hope you get this.